turn it over to Devan.
Hi, everyone. My name is Devan, and I'm a rising junior at La Jolla High School in San Diego, California. And for Blue Stamp this year, I did the Arduino obstacle avoiding robot. I was hoping Gino was gonna give you an introduction to that, but I will give you that introduction in a second. I accomplished a lot at Blue Stamp during these 6 weeks. I have a lot of modifications that I'm proud of on top of the obstacle avoiding robot, so I will show you that in a second. This is going to be one of the longer presentations just because 6 weeks is a very, very long time, and I accomplished a lot, so I really want to share that with all of you. I'm going to give you a demo right now of how everything works. Let me try to share my screen. Oh, wait, hold on. Let me share with audio so you can hear. There we go. Okay.
Welcome, Devan. I am your obstacle avoiding robot from Blue Stamp Engineering. Please connect to the Bluetooth module. Connection successful. Please choose a mode. You are now in voice command mode. You now have full control.
Go forward. Stop. Go back. Stop.
You are now.
That's impressive.
Now in obstacle.
It might be lagging. I'll rewind just a little bit.
Motion detected. Motion detected. Motion detected. Motion detected. You have chosen to disconnect. I will now power down. Have a great day.
Okay, so that is my project. Let me stop share screen so you can see me. So obviously, that's a lot of information to take in at once, so let me break it down. Week 1 and week 2 of Blue Stamp, I was able to do the obstacle avoiding robot, which was the base project. And what was really important about this is that it laid the foundation for everything else to come. I know a lot of my peers here are going to do the obstacle avoiding robot, but what's really cool about this project is that you can add a bunch of modifications and make it your own, really. So basically, I'll just give you a brief intro of how it works. This is an ultrasonic sensor here, and it basically works as an echolocation sensor. So it sends pulses out and then reads them back, and that's how it's able to gauge distance, and then is programmed to stop at a certain distance and turn. So that was what I accomplished after 2 weeks. Into week 3, I decided to integrate voice control with this new Samsung that Blue Stamp sent me. Hold on, okay. So here's the app right here. I designed this app on MIT App Inventor, which was a really cool experience because I've never even done engineering, much less making my own app, which was really cool. Right here is a voice recognition software right here, and all it does is that it recognizes what I say. So if I were to say, go forward, like I did in the video, I don't know if you caught that, the video was a little bit laggy, but if I did, if I were to say go forward, I have it assigned to an integer. So I'd say go forward equals 1. And then what it does is that this phone sends 1 to the Arduino on this robot, and then the robot carries out that function because I assign integers to different functions. And then I also have remote control buttons here that let me control that, and that's the same type of logic. And then that's week 3. Let's go into week 4. I added a micro servo here, and essentially what this servo does is it lets the robot look back and forth, left and right, and what that does is that it essentially allows it to gauge the room. So it allows it to look forward, then look left and look right, and then detect which obstacles are where, and then when it's turning, it either will turn left or right depending on the distance each direction. And so that's a great modification because before I just had it turn clockwise, so that had increased intelligence to the robot. Next, I added LEDs right here, and I actually only did this because I was waiting for something in the mail, but and these Adafruit NeoPixels were the only thing here that was really cool. So I added that, and it ended up being a very cool experience just because I expected it to be super easy, but it ended up being one of the hardest things about this project. They're very power hungry, and so it drew a lot of power, and I will get into that a little bit later. Essentially, how these work is that I programmed it so that when the robot is within 80 centimeters of anything, the lights will turn on and they will get incrementally brighter until about 15 centimeters. And then, I don't know, it also lagged in the video, but it blinked 3 times. And I just did that to give kind of a visual aspect of the obstacle avoiding function. And I made it red because I'm into aerospace engineering. That is my interest. And I kind of wanted to emulate the Mars rover, and I thought red would be a cool color. And lastly, I have this motion detector here. And all that does is motion detects mainly if humans are near there. So if a person walked by like I did, I kind of touched it a little bit and put my foot next to it. It turns blue. I had the LEDs shine blue. And then I had it send a message to my phone saying, oh, motion detected. And one problem with this was that it wasn't very reliable. So I'm actually currently in the process of making that more reliable right now. Um, I had so many challenges with this project, mainly mechanical because I have a background in code. So I just wanted to say that. So each one of these obstacles that I overcame, it was just a really great experience because then I could understand my robot further. One such example is when I told you that the LEDs were power hungry, I had to add a second battery pack right here. And what that did was just really insane. It fried my motor driver and I had to replace half of my materials here and rewire and then adapt the code to let it convert to 2 battery packs now and more power. One example was just lowering the speed because more power makes it go way faster. And then moving forward, what am I going to do after BlueStamp? I really want to add a camera on this side of the robot. So instead of when it sees something in the way, instead of sending me, oh, motion detected, it'll say motion detected, and then it'll show me a picture of what is there. So that is also kind of a Mars rover kind of thing. Um, I was trying to do that this week, but there are many logistical problems. One, I just didn't have enough time and enough energy, and I really spent like Rachel can attest. We were spending all of yesterday trying to figure a bunch of things out with my robot pre-demo night, and once I figured out that you know what, it just can't be done, and it was just a great lesson to learn because it showed me that engineering takes a lot of motivation and perseverance. So I'm gonna take that further post BlueStamp and try to figure that out on my own. During my time at BSE, it really helped me understand robotics and software engineering. I really did not have a background in engineering at all. I came to BlueStamp to learn more about engineering. I had an interest in design and mathematics and architecture, and it just really strengthened that interest. BlueStamp has taught me about communication skills, problem solving skills, and really gave me a place to go during this pandemic because it's been a little bit boring. But with this BlueStamp remote program, it really helps me learn something new every day and keep my mind engaged. And it was a really fun experience. Now I'm ready to move on and show the world what I got now. That's it. That's my presentation. Thank you for watching. Are there any questions? Nope. Okay. Thank you, everyone.
Well said.